For this video, we're going to look at the function f of x equals x to the 7th, and we're going to describe it in words, and then we're going to define it, meaning we have an equation, using g of x. So g of x is g because it's not really the function f, so we're going to use g of x to say this is a new transformed function. Under describe for number 1, we notice that f of x is really y, and then we're really taking y plus 2. So every time we take a y value for that function, we're going to add 2. And to describe that, we're going to say that it is translated. And if we're changing the y values and they're positive, we're going to say it goes up 2. And then for the transform function, we now know that our new function, g of x, is really equal to f of x plus 2. And we know that f of x is x to the 7th, and then we're adding 2 every time. Number 2, 3 times f of x, which is really 3 times y. So every y value is going to be tripled. So that means this function is going to be stretched vertically. So we are going to write in our description, stretched vertically by factor of 3. And we say factor because factor means multiplication. So we're multiplying 3 times the function. And stretched meaning if I take a balloon and I stretch it towards the sky, it actually gets narrower, but it is a stretch vertically. In our transformed function, we know that our new function we're going to call g of x. And we're going to set that equal 3 times the function f of x. So we're going to take 3 times the function f of x, which is really x to the 7th. On number 3, we have f of a negative x. So in this case, every time we see x, we're going to plug in a negative x. So if I were to look at the original f of x, wherever I see x, I'm going to put in a negative x. And when I do that, if I take a positive x, a positive 3, and make it a negative, then it becomes negative 3. So what it does is reflect over the y-axis. In the same respect, if I take negative 3 and take the opposite sign, it becomes a positive 3. So it flips back and forth across the y-axis. So I would say that this is reflected across the y-axis. And if I look at the actual function, I have g of x, and I am taking x and replacing it with a negative x. So I'm actually going to take the x value, replace it with a negative x, and then it is still to the 7th power. For number 4, f of x minus 2, I'm going to take my base f of x function, and instead of x, I'm going to put in x minus 2. And if I take an x value and subtract 2 from it, we think that we're going to the left. But what we're actually doing is going to the right because our x value is 2. If we subtract 2, we get back to 0. And what we're really doing is taking the function with a vertex 0, 0 and shifting it. So if I shift over to an x value of 2, I really need to subtract 2 to get back to the original 0. So we're always opposite when we're in parentheses with the x. So in this case, for number 4, that means that it is translated 2 units to the right. And if I look at the function g of x, I have g of x. And in my original function, I had x to the 7th. But what we're really going to place in is x minus 2 instead of x. For number 5, we have 1/3 f of x, which really means 1/3 of y. So every y value is going to shrink by a factor of 1/3. So I'm actually going to have a shrink, because the y values are getting smaller, shrink by a factor of 1/3 vertically. If I look at the function, I have g of x is equal to 1/3 the original f of x, which was x to the 7th. For number 6, we look at the function of 3x, so that means f of x, I'm really replacing the x with 3x. So that means I have to triple the x in order to get my y value that I had before. So I'm really looking at shrinking it on the horizontal axis. But as far as we're going right now, we're only looking at vertical, and we're only looking at plugging in that 3x. So we're going to say for right now that we have a shrink by a factor of 1/3, because it's always opposite of what's in parentheses, of 1/3 horizontally. So whatever we do horizontally with the x is always the opposite of what we think. And then if I put in my g of x instead of x, because my original is x to the 7th, instead of x, I'm going to put in a 3x, so it's 3x to the 7th instead. For number 7, if I'm looking at f of x, it's y and then minus 2. So every y value is going to move down 2. So I'm going to have a translation down 2. And if I look at my g of x, I'm going to take g of x, and I'm going to put in my original f of x, which is x to the 7th, and then I'm going to subtract 2 from that every time. On number 8, we have negative f of x, so we're going to have a negative f of x is really y. So negative y, so like the negative x at the top, we take every y value and flip it to a negative, or every negative value we take the opposite sign and make it positive. So if it's a positive 4 on the y, we're going to make it a negative 4, so it flips over the x-axis. So in this case, we have a reflection over the x-axis this time. So it's the opposite of what you think. At the top we had negative x, which meant it went over the y, and in this case we have a negative y, which means it goes over the x. And if I look at g of x is equal to a negative f of x, which is really x to the 7th. Finally, number 9, we have f of x plus 2. So we know that we start off with f of x, and instead of x, we're going to plug in x plus 2. And like we said before, if I have a value for x, and I want to get back to the original 0, I need to do the opposite. So if I'm at a negative 2, I would have to add 2 to get back to that 0, 0 point for the vertex. So in this case, where it says x plus 2, we have to do the opposite for x. So we're actually going to translate 2 units to the left. So for the x is the opposite, for the y it is the right number because the y value isn't actually with the translation. So we're going to move left 2, and then that means that on g of x, we're actually going to take the x value. So g of x is x to the 7th, so in this case we're going to take and replace x with x plus 2, and it's x plus 2 to the 7th instead.